This video is a submission from University of Calgary's team for Phase 1 of the 2019-2020 Drillbotics competition. We will go over the proposed drill rig design, control systems, and data visualization. Overall rig. The structure from last year's rig was robust and compact, which allowed for easy transportation and a stable drilling operation. Therefore, the rig frame for 2020's competition will be the same as last year, with some modification for this year's design to accommodate the implementation of directional steering mechanism for a three-dimensional control of the drill. The drill rig consists of a mast frame, top drive carriage and slider assembly, rig frame, bottom hole assembly, wellhead, drill string, and a rock sample housing. The mast frame is constructed with T-slots and has a modular retractable design for easy transportation. The major changes in this year's design will be implementation of a cable steering mechanism to achieve directional control, modified BHA to accommodate the proposed steering mechanism, modifications to the wellhead to allow for azimuthal change. The BHA design from last year will be utilized for this year's competition. Here is a section view of the BHA, which houses a series of universal joints inside to transmit the torque from the top drive to the drill bit. The BHA itself is made up of multiple pin-connected joints, and so the bend in each link allows the entire BHA to bend and operate in a bent configuration. On the outside, there are two cables running parallel to the BHA connected to the last link at the bottom to achieve directional drilling. The last link also includes the downhole sensor housing, which houses the Bluetooth sensor. The other end of the cable is wrapped around a spool which is connected to the servo motor with a keyed shaft connection. The motors will be used to produce tension in the cables, and through unequal tensions in the two cables, the assembly can be made to bend in a direction. The wellhead has been modified for this year's competition. It uses a turntable mechanism with a linear actuator to facilitate the third degree of freedom, that is, the azimuthal change. The assembly has been constructed from commercially available standard-sized products.
The main addition to this year's control system is a directional control system, which will act independently from the top drive control. The interaction between these controls will be handled by a supervisory control, as shown. The supervisory control will also deal with the input lag of the directional steering and the sensor array. For the directional control, the wellhead will rotate to the correct azimuth before the drill turns on, which will allow us to treat the directional control as a 2D system after the initial rotation. Targets will be added to the program in the approximate path of the drill. This is shown in the top right corner. We will use an accelerometer to determine inclination and an optical encoder to determine vertical depth, which we will then use together to calculate the position of the drill bit in real time. The directional control will kick in when the angle between the current drill bit direction and the target position is greater than the angle of our control mechanism. As the targets are passed in either the X or the Y direction, the next target will be chosen and the directional control will reorient it around the new target. The data collected from the drill run will be stored in a Microsoft SQL Server database that will also hold the targets the directional control will seek to hit. We will use a Simulink box to execute the control system and a Raspberry Pi to receive and relay the information back to the rig, as well as decode any analog signals as necessary. Finally, the information will be visualized using a simple Unity program, as shown, that will take the coordinates directly from the database. Thank you for listening to our presentation.